4.5 Part 3 talks about the properties and the graphs of the cotangent, cosecant, and secant functions. So let's start out here first with our cotangent function. Cotangent, remember, is a reciprocal of tangent. So it's going to look similar to tangent. It's a reciprocal, so it's going to be flipped upside down, which means we're going to start at the top and go down instead of like tangent that started at the bottom and went up. Alright, but we also have to be careful for tangent because remember that cotangent, because remember cotangent is x over y. So when we look at our unit circle, anywhere that has a y value, cotangent is going to be undefined. Anywhere that has a y value that's 0, cotangent will be undefined. Alright, so cotangent is also going to have those asymptotes. It's kind of like sine and cosine, how they look similar, but one of them was shifted. Tangent, cotangent will be similar. It's going to be flipped upside down, and one of them is going to be shifted. Alright, so let's see. Cotangent. Let's start with 0. At 0, you have the ordered pair 1, 0, which means y is 0, so therefore it's undefined. So just like with tangent, I'm going to start out with my asymptotes, have the graph, and end with an asymptote. So then we know that cotangent is like tangent, therefore its period is pi. So let's go ahead and do our x's. I'm sorry, I got a little ahead of myself there. So we're going from 0 to pi. Halfway would be pi over 2. Halfway between 0 and pi over 2 would be pi over 4. And halfway between pi over 2 and pi would be 3 pi over 4. Okay, so now that we know that, we can look at our ordered pairs and we can figure out the rest of the table. So pi over 4, if I took its ordered pair and I did x over y, I would get positive 1. Pi over 2, take its x over y, we get 0. 3 pi over 4, take its x over y, you'll get negative 1. And pi, take x over y, you will again get undefined. So therefore, this is our unit table for cotangent. And so we can graph that. Again, undefined is just going to be an asymptote, vertical asymptote. So pi over 4, 1. Pi over 2, 0, 3 pi over 4, negative 1. And so we can draw our graph. And we can see there that it is very similar to tangent. It's flipped upside down, and instead of starting at negative pi over 2, we actually started at 0, so it's been shifted. And again, just like before, we could follow our pattern. We could draw another one going to the right. Or we could draw another one going to the left. Alright, so let's talk about some key features that they go through here. Okay, the domain. Again, you know, because you have asymptotes, your domain is not negative infinity to infinity. So let's talk about where x cannot be. So again, find a vertical asymptote. So how about it's 0? And then how far apart are each vertical asymptote? Well, each one of them is a pi. So I'm going to have vertical asymptotes at 0 plus pi n, which means that's where the domain cannot be. Now 0 plus anything is just anything, so we could put x cannot equal pi n. Your range, just like tangent, it keeps going up, it keeps going down, so negative infinity to infinity. Your zeros are your x-intercepts. Let's go find one of them. So I see that we have one at positive pi over 2. So we could say our zeros are going to be at pi over 2. And they're going to occur every pi as well, so plus pi n. And remember, n has to be an integer. And then it talks about the vertical asymptotes. Well, we already talked about those. We said that's where the domain cannot be. So it's at x equals pi n. Again, even, odd, or neither. Well, we had said only cosine and its reciprocal are even, so that means that tangent is odd. Cotangent is odd, which means that it's symmetric to the origin. It also means that if we took cotangent of negative x, it would give us the same answer as cotangent of positive x, except it would be the opposite sign. And then again, we said that the period is equal to pi.